Hello all. In this lecture, we will discuss the problem of finding general solution to the first order quasi-linear PDE. So let us discuss the problem. Number 1. Find the general solution of minus y into ux plus xuy equal to 0, and we call it as equation number 1. So we have to find the general solution of equation number 1. So we know that by Legrange method, the general solution will be of the form f of psi of x, y, u and phi of x, y, u equal to 0, where phi of x, y, u equal to alpha and psi of x, y, u equal to alpha and phi of x, y, u equal to beta are two integral surfaces that contains the characteristic curves. So now we have to find the functions phi and psi and phi. We have to determine this, and from the construction of this Legrange method, in order to find this function psi and phi, first we have to take two vector fields p1 and p2 so that both are independent and orthogonal to the vector p, where the vector p is a, b, c. Now from the equation 1, we know that equation 1 is a quasi-linear PDE where the standard form is a of xyu into ux plus b of xyu into uy is equal to c of xyu. Okay, so from this a is equal to minus y, b is equal to x and c is equal to 0. Therefore, the vector p will be minus y, x and 0. So we have to take p1 and p2 such that both are independent. Both are independent means they are not in the same, they are not tangent each other, and they will be perpendicular to the vector ABC. From the ABC is minus y, x 0. So we can take without any loss of generality, we can take it as p1 as x, y 0. So when we take the dot product, perpendicular means their dot product will be 0. That means p1 dot p will be equal to 0 and this will be equal to p2 dot p. Okay. So when we take the dot product x, p1 dot p, so it will be minus y into x, that means minus xy plus x into y. So that two terms will be cancelled and plus 0 is coming. So in total that dot product will be 0, and we take p2 as the vector 0, 0, 1. Okay, so that these two conditions are satisfied. The two condition means first condition is the two vector fields are independent and perpendicular to p, and to find psi and phi, then from the construction we have it is clear that the vector fields p1 and p2 must be exact. This must be exact. That means we have to prove delta cross p1 is equal to 0 and delta cross p2 equal to 0. So this you have to verify. So verify that both the vector fields, when we take p1 as xy 0 and p2 as 0, 0, 1, then we have to prove that both are exact. Then if the two are exact, then we can find scalar potentials phi and psi such that del psi is equal to the vector p1 and del phi equal to p2. Okay, so from these equations for the potential, if del psi equal to p1 and del phi equal to p2, we can calculate the functions phi and psi. Okay. We consider the equation del psi is equal to p1. We take the equation del psi is equal to p1 and we know what is del. Del is the gradient that means dou by dou x, dou by dou y and dou by dou u. So this is our del. So del psi means, so del psi will be dou psi by dou x comma dou psi by dou y comma dou psi by dou u. So this will be del psi. So del psi must be equal to P1. And what is P1? P1 is P1 is minus y x. P1 is x y 0. So combining both, we have dou psi by dou x comma dou psi by dou y comma dou psi by dou u is equal to x y 0. Then equating each one, we have dou psi by dou x is equal to x, dou psi by dou y equal to y and dou psi by dou u equal to 0. So we have three relations, dou psi by dou x, dou psi by dou y and dou psi by dou u, where psi is a function of x, y and u. Three variables are there and three partial derivatives are we know, and we have to find psi from these equations. So we will take the simplest one, dou psi by dou u equal to 0. So from this we know that psi will be of the form, integrating this equation with respect to u, we will get psi of xyu is equal to, the 0 means, that means when we differentiated psi with respect to u, its derivative is 0. That means psi will not contain any function of u. That means psi will be a function of, we can write psi as a function of the function in the remaining two variables. That means a function in two variables x and y, isn't it? Because suppose if psi is equal to some x plus y plus u, then what will be dou psi by dou y, dou psi by dou u? It will be 1, cannot be 0. So if there is any function of u in the psi, then dou psi by dou u cannot be equal to 0. So we can write it as psi as is a function independent of u. That means it is a function of x and y alone. Otherwise this can't be 0. Okay. So from that we can write psi as psi of xyu as phi f of xyu. Let this equation be number 2. Now differentiate 2. Now we have to take these two equations, isn't it? For that we have to find the derivative with respect to x and derivative with respect to y. So we will take one by one. So first we consider dou psi by dou x. So now we have psi as is a function of f of x comma y. Now differentiating equation number 2 with respect to x, what we will get? We will get, the left side will be dou psi by dou x is equal to, now f is a function of two variables x and y. So we with respect to x differentiate cheyannu parnal, we will get the partial derivative of f. And from the this equation from this one, from this equation we have dou psi by dou x is equal to x. So we can write it as this is equal to x. ഓക്കെ, ഇത് നമുക്ക് എക്സ് തന്നെ എഴുതാം. ദാറ്റ് മീൻസ് ഇപ്പോൾ നമുക്ക് എന്താ കിട്ടിയിട്ടുള്ളത്, ഡോ എഫ് ബൈ ഡോ എക്സ് എന്നുള്ളത് എന്താണ്, എക്സ് ആണെന്ന് കിട്ടി. ഇത് മാത്രം കൺസിഡർ ചെയ്യാം. ഡോ എഫ് ബൈ ഡോ എക്സ് ഇസ് ഈക്വൽ ടു എക്സ്. ഫ്രം ദിസ് വി ക്യാൻ ഫൈൻഡ് എഫ്. സോ ഇൻ്റഗ്രേറ്റിംഗ് ദിസ് ഇക്വേഷൻ we have f is equal to, when the right side function x ആണ്, so x നെ integrate ചെയ്താൽ we will get as x square plus 2. now plus 1 integrating constant is there, but that is not an c. it can be, we know that f is a function of x and y. എക്സിലും വൈയിലുള്ള 2 വേരിയബിൾ ഉള്ള ഫംഗ്ഷനാണിത്. അപ്പോൾ അതിനെ നമ്മൾ എക്സിൽ ഡിഫറൻഷ്യേറ്റ് ചെയ്തപ്പോൾ എക്സ് എന്നാണ് മാത്രമാണ് വന്നത്, അതായത് വൈ ടേം ഒന്നും തന്നെ ഇല്ല. അപ്പോൾ അതിൽ എന്താ പറയുക, ഇവിടെ നമുക്ക് എഫിൽ മേ ബി എനി ഫങ്ഷൻ ഓഫ് വൈ may exist or may not. So when we differentiate this, we will get again it as x itself. So instead of integrating factor, we have to take it as a function of y, since f is a function of 2 variables x and y. So now we again reduced f. So substitute this in equation number 2. So substituting 3 in 2 implies 3 2 substitute ചെയ്ത് കഴിഞ്ഞാൽ നമുക്ക് എന്താ കിട്ടുക, psi of x y u is equal to what we will get, x square plus 2 plus f2 of y. So ഇപ്പോൾ ഇങ്ങനെയാണ് കിട്ടിയിട്ടുള്ളത്. ആൻഡ് പുട്ട് ഇറ്റ് ആസ് ഇക്വേഷൻ നമ്പർ 4. അങ്ങനെ നമ്മളൊരു നമ്പർ 4 എന്ന് വിളിച്ചു. Now so our equation number 4 is psi of x y u is equal to x square by 2 plus some function of y, let it be f2 of y. So f2 of y എന്ന് വന്നു. ഇനി നമ്മൾ എന്താ ചെയ്യേണ്ടത്, ഇനി വീണ്ടും ഒന്നുകൂടി നമ്മൾ എടുക്കാത്ത ഒരു ഇക്വേഷനും കൂടി ഉണ്ട്. അപ്പോൾ അതിലേക്ക് വേണ്ടിയിട്ട് നമ്മൾ വൈയിൽ ഡിഫറൻഷ്യേറ്റ് ചെയ്യുന്നു. ഈ f2നെയും കൂടി നമ്മൾ എലിമിനേറ്റ് ചെയ്തിട്ട് നമ്മൾ psi ഇൻ ടേംസ് ഓഫ് എക്സ് വൈ യു ആയിട്ട് നമുക്ക് ഫംഗ്ഷനായിട്ട് കിട്ടണം. സോ ഫോർ ദാറ്റ് വി കൺസിഡർ ഡോ psi ബൈ ഡോ വൈ, അതായത് ഡിഫറൻഷ്യേറ്റിംഗ് വിത്ത് റെസ്പെക്ട് ടു വൈ. ഈ ഒരു ഇക്വേഷൻ നമ്പർ 4 ആയിരുന്നു. സോ ഡിഫറൻഷ്യേറ്റിംഗ് ഇക്വേഷൻ നമ്പർ 4 ബൈ വിത്ത് റെസ്പെക്ട് ടു വൈ, വി വിൽ ഗെറ്റ് ദിസ് ആസ് എക്സ് സ്ക്വയർ ബൈ 2നെ വൈയിൽ ഡിഫറൻഷ്യേറ്റ് ചെയ്യാൻ മീൻസ് it will be 0. So f2 dash f2, now f2 is a function of y alone. So instead of the partial derivative, we can write it as df2 by dy or f2 dash of y. Now we know what is dou psi by dou y, and dou psi by dou y is y itself. So we have f2 dash of y is equal to y itself. Now integrate this one. So this is df2 by dy. So integrating this, we will get it as f2 of y equal to some y square by 2. Some y square by 2. Now there is no need of writing the plus c here, because thing is that when we talk about the solutions, f of psi comma phi equal to 0, actually it is psi of xyz equal to c1 and phi of xyz is equal to c2. So there is already constant is there, so we are not taking the constant here. So from this equation number 4 becomes psi of x y u is equal to, psi of x y u is equal to what, x square by 2 plus y square by 2. Okay, so psi of x y u is equal to x square by 2 plus y square by 2. So now we obtained one function psi of x y u. So this is equal to half of, we can write it as half x square plus y square. So in the similar way, we have to find phi of x y u in terms of x y and u. So that we will continue in the next lecture. Okay, thank you.